Hello to everyone. My name is Miroslav Kostadinovic and I am from the University of East Sarajevo, Faculty of Transport and Traffic Engineering, Doboj, Bosnia and Herzegovina. I'm a first author of the paper analyzing performance of wireless network based on the industrial HART protocol. Other authors are Dalibor Dobrilovic, Gordana Jotanovic, Goran Jausevac, Zeljko Stojanov, Vladimir Brtka. Our email addresses are presented on the last slide so that you can contact us due to the paper related information or future cooperation. Modern control systems in the process industry increasingly use wireless data transmission to send out information from a sensor located directly at the site of a process to the central control unit. There are numerous reasons for such an approach. The most common reason for choosing a wireless industrial communication network is the cost of installation, since eliminating or significantly reducing cable usage means significant savings in cable and installation work. In other words, the cost of new installation, maintenance, and repair is lower than the corresponding cost for cable solutions. And wireless technology opens up a new field of application in terms of how measured process data is transmitted. Costs in wired networks can be even higher if there is a need to expand existing infrastructure to include additional measurements. While adding new measurement allocation in wireless networks represents a small cost and significantly reduces the economic barrier that exists in wired networks. The application of smart manufacturing systems and the expansion of the Industry 4.0 model have created the need to modernize existing industrial environments. One way to modernize existing factories is to use wireless technology in monitoring, controlling, and managing industrial processes. The applicability of wireless HART technology in the industrial environments as a wireless technology capable to support system requirements is investigated in this paper. The rest of the paper is organized as follows. Section 2 gives some insight into related work. Some details on IEEE 802.15.4 standard and wireless HART are given in Section 3. The approach of the wireless HART system is described in Section 4. Section 5 describes the experiment of wireless HART performance analysis as well as results discussion, while final Section 6 gives the conclusion and possible future work. Wireless HART and 802.15.4 overview. Wireless HART is a wireless sensor networking technology based on the Highway Addressable Remote Transducer Protocol, or HART. Wireless HART is based on the physical and MAC layers of the IEEE standard 802.15.4. The IEEE standard 802.15.4 defines the physical and MAC sublayer for low-rate wireless personal area networks. The standard specifies physical as it is shown in Figure 1. Wireless HART system architecture. The number of devices that can be connected to the wireless HART network via the wireless gateway depends on the update interval of the data that device sends to the wireless gateway. For example, if each device in the wireless HART network sends updated data every 60 seconds, then the wireless gateway can support up to 100 devices. The maximum allowed update interval is 1 hour. Update intervals shorter than 60 seconds are predefined in exponents of number 2, such as 4, 8, 16, or 32 seconds. However, the shorter the update interval, the shorter the battery life. Practically, the shortest update interval for this generation of equipment is 8 seconds, although there is a choice of 4, 2, or 1 second. In the closed space of the industrial environment, There are obstacles that are on the line of communication between the devices within the realized wireless network. The enclosed space architecture with the marked wireless gateway position and the numbered device positions, wireless transmitter or node, together with the indicated distances between them, were organized for the experiment. The wireless HART architecture shown in Figure 2 contains the following elements. Number 1, it's a host system. Number 2 is wireless gateway, and number 3 is wireless transmitter. Host system consists of the host computer and appropriate software applications that allow monitoring, control, and management of industrial processes. Data collected with the help of wireless HART does not always belong to the control system, as some measurement points can only be used for monitoring or management. They can also be used for real-time control in certain applications. Host systems should be such that data packet from the wireless HART network is delivered to the host computer via the gateway. Wireless HART data can be routed through the shared network resources, like data collected on liquid level in industrial tanks, data collected on the vibration spectrum, data collected on fluid pressure, data collected on the temperature state of the observed industrial systems, and so on. Wireless gateway. Wireless gateway is very important when designing a wireless HART system. The wireless gateway connects wireless self-organizing networks to the host system. The reliability of wireless gateway is ensured by the IEEE 802.15.4 radio standard, 2.4 GHz ISM band sliced into 15 radio channels with time synchronized channel, hoping to avoid interference from other radios, Wi-Fi and AMC sources. Important characteristics of the wireless gateway are easy configuration and management of self-organizing networks, easy integration into control system and data applications via serial and Ethernet connections, and wireless capabilities are expanded with the advantage of using in inaccessible locations. Wireless transmitter. Wireless transmitter are devices that connect to the gateway and enable fast, reliable, and secure data transfer. Often the wireless transmitter includes sensors that gather information from industrial environments. Wireless HART devices include wireless transmitters with temperature, pressure, flow, level, and other process variable sensors. Wireless transmitter in the wireless network offering dual channel, discrete inputs and discrete outputs. Discrete single or dual switch input with logic for limit contact and opposing contact applications. And dual channels are each configurable for discrete input or discrete output. Here we can see results and discussion. The experiment took place in a laboratory environment. The experiment setup is as follows. The wireless gateway is placed on the wall in the far left wing of the laboratory as it is shown in Figure 3. The wireless transmitter or node 2 is placed in the fixed location near the wireless gateway. The wireless transmitter or node 1 is portable and it is used to test the wireless HART network performance at 4 different distances of 5, 10, 20 and 30 meters. The results of the tests are presented in the following tables. The overall network statistic is given in Table 1. Each location displays the results for Node 1, Node 2, and wireless gateway respectively. The results are for the number of neighbors connected, reliability of the links, missed updates, path stability, received signal strength indicator, and joins. The results give the similar values of RSSI for different locations, giving the conclusion that according to the results, the distance in this area of coverage does not have significant influence on the RSSI level. Table 2 shows the results for the node 1 statistics. Here the results are focused on RSSI values in direction to and from the neighbor. The results are slightly better for the distance of 5 meters and slightly worse but almost equal for other distances. The path stability is almost 100% in each scenario. Table 3 shows the results for the node 2 statistics. Here the results are almost similar as table 2 for node 1. The only difference here is the better results for 30 meters of node 1's signal strength comparing to shorter distances. This small deviation from the expected results can be explained with the institutional or building layout, like wall, furniture, and other obstacles. Table 4 shows the results for the burst statistic with the focus on latency in the network. The latency here gives the very good results. This is of high importance for the planning possible applications of wireless HART in the given system because the latency is crucial for optimal network performance in given system. Table 5 shows the results indicating overall network performance. Here the most important parameter is the number of burst messages, showing the intensity of network traffic. Again, average latency in 15-minute interval and latency lifetime are very good for potential usage of the system. Conclusion. In this paper are presented test results and the usage of wireless HART technology in the industrial wireless sensor network. Industrial wireless HART system must have a consistent node connection to the gateway regardless of obstacles in the environment. Consequently, the latency and general network performance are of great importance for the response of the entire system. In the experimental wireless HART system, the problem of signal transmission obstacles was solved by introducing node 2, which allows a redundant path between gateway and node 1 for different distances. In this case, the latency has low values and the communication between the node and the gateway is better with a low transmission packet error rate. Also, the experiments with wireless HART technology are interesting because this technology is based on IEEE 802.15.4 physical layer, designed especially for wireless personal area networks. This proved to be important for ZigBee, wireless HART, 802.15.4G SUN, 6 low VPN, and so on. The experiments took place in laboratory environment with 3 nodes. 2 nodes were fixed and 1 node was portable. Results and discussion presented in section 5 justified the applicability of wireless HART technology in the industrial environments as a wireless technology capable to support system requirements. The wireless HART, with its features such as low latency and low packet error rate, low number of errors on the specified distances, showed to be highly applicable in the system for the industrial monitoring. The most important performance parameter analyzed in this research is latency. The low latency values justify the applications of the wireless HART in the given system because the latency and better network performance in general are crucial for the fast response required in this system. In the future work, the coexistence of the wireless HART with other wireless technologies operating in the 2.4 GHz band, like IEEE 802.11 and Bluetooth Low Energy, should be examined as well. Thank you for your attention. Do you have any questions for authors? The authors' email addresses are on the first and last slides.